Good day to you all out there. I'm welcoming you to Science Explained. Today, I am continuing from where I stopped at episode 2 of the topic trigonometry. These were the questions I left unsolved at the end of episode 2. I will pause the video for you to have a try at these questions. At the end of watching this video, if you appreciate the teaching, please do not hesitate to subscribe to my channel, Science Explained, and as well, share for others to have a taste of this. Now, let's go and solve this problem. In the previous episode, I talked about complementary angles. Now, there is a condition given here that if theta is an acute angle, if theta is an acute angle. What's an acute angle? Any angle less than what? Less than 90 degrees. All right. That means I need to look for complementary angles. The two angles that when added together gives 90 degrees. You can find all this information in the previous video, in episode 2. So what I'm going to do is either I change sine to cos or cos to sine, either of the two. Okay, which one will be more preferable? Changing sine to cos will be easier and faster. Why? Because there is a symbol theta involved here, whereas there is nothing like a symbol here. All we have here is a value. That means I can easily subtract 40 from 90. Don't forget, complementary angles mean two angles added together to give 90 degrees. Therefore, changing this sine to cos. First step, sine 40 degrees is the same thing as cosine of 90 minus 40 degrees. Since 40 plus its complementary will give us 90. All I need to do is to subtract 40 from 90 to get the other complementary angle to 40. And that will give me cosine of 50 degrees. Meaning that cosine 50 degrees will replace this now. So, next step, which is second step, I'm going to have cosine 50 degrees replacing sine 40 equals to what we are given originally, which is cosine of theta plus 15 degrees. Obviously, cosine will cancel out cosine. So what we have left is 50 degrees equals theta plus 15 degrees. So, by collecting like terms, I will bring 15 to this other side in order to find theta. That means 50 degrees minus 15 degrees equals to theta. Don't forget that plus 15 crossing here become minus 15. And that means that theta equals to what? 35 degrees. So if you want to test whether you are correct or not, go and substitute theta here with 35. When you substitute with 35 plus 15, that will give you 50. That means sine of 40, if you press your calculator, whatever you get is what you get when you press the cosine of what? 50 degrees. Because 40 and 50 are complementary angles. Now, the second question. Roman figure 2. That is cosine of theta equals to sine of 20 degrees. As I did in the first question, this will be easier to convert because theta is a symbol, 20 is a number. So all I will do now is, first step, I want to convert sine 20 so that it becomes cosine that we have here, and that will be cosine of 90 minus 20. I am subtracting this 20 from 90 because I'm looking for the angle that will complement 20 degrees. And don't forget, complementary angles are two angles added to give 90. So that means I have sine of 20 degrees equals cosine of 70 degrees. Meaning that I am going to use cosine of 70 degrees to replace sine of 20 in the original question. So what do I have? I have cosine of theta equals cosine of 70 degrees. I'm writing cosine of 70 degrees instead of sine of 20 degrees. Cosine will cancel what? Cosine. What is theta? Obviously, is what? 70 degrees. All right. The third question now. I'm going to use same approach to solve it. Okay. Sine of theta minus 10 degrees equals to cosine of theta plus 40 degrees. Now, both sides of the equation has the symbol theta, so we have no choice but to choose any one we feel convenient with. Do you want to change sine to cos or cos to sine? Whichever one, you get the same answer. I want to change sine to cos. So what do? That means first step, sine theta minus 10 degrees will be equal to cosine of, I will now subtract the whole of this from 90. That will be 90 minus open bracket theta minus 10. Bracket closed. It's very important you take note of this. If you don't open this bracket, this small bracket, this inner bracket rather, the negative sign here will not affect this term, and that will be a mathematical error. Don't forget, I am subtracting the whole of this from 90. So definitely I have to put it in a what? In a parenthesis. So what do I have? That means sine open bracket theta minus 10 degrees will be equal to cosine of 90 minus times theta, that will minus theta, minus times minus 10 will be plus 10. So I'm going to use this to replace this sign here. Therefore, I have cos of 90 plus 10. That will give me 100 minus theta equals to cos of theta plus 40 degrees. Okay, cos we cancel what? Cos. What do you have left? 100 minus theta equals theta plus what? 40 degrees. If you collect the right terms of theta, if this theta comes here, this minus theta comes here, it becomes positive, while this 40 comes here, it becomes what? Negative. So what do we do? Or what are we going to have? Then we are going to have that will be 100 minus 40 equals theta plus theta. And 60 degrees will be equals to 2 what? Theta. You divide both sides by 2 in order to find theta. So definitely theta equals to what? 30 degrees. Now, I want to start dealing with trigonometry identities. This is an important and critical and sensitive area of trigonometry where students find it very challenging. The ability of the student to recall identities makes any problem on trigonometry to be easy to solve. In fact, you will need this in the areas of calculus while differentiating or integrating trigonometric functions. Please come along with me and see the breakdown. The first identity, which is very important, is this. Tan of theta is equal to sine of theta divided by cos of theta. Always. How do we arrive here? Let's go to the 4 quadrants we have there. This is a triangle that has been established. X axis, y axis. That means this side, which is vertical, is also y because it's parallel to y axis, and this x. Using SOHCAHTOA, what will be sine of theta? Sine of theta will be opposite over hypotenuse, which is y over r. Cos of theta will be adjacent over hypotenuse, which is x over what? R. So obviously, sine theta divided by cos theta, sine theta divided by cos theta, or rather, what will be tan? So, which is sine theta over what? Cos theta. What is sine theta? Y over r divided by what is cos theta? X over what? R. So according to mathematics, this will turn upside down. We have y over r times r over x. R cancel out r, which is y over what? X. So definitely, tan what? Theta equals to what? Y over x. And if we go and find out tan theta from this, obviously, tan theta, which is what? Opposite over adjacent. What is opposite? Y over what's adjacent? X. So you can see that the result from here is the same thing as the result obtained here. That's to tell you that truly tan theta is sin theta over cos theta, because sin theta over cos theta gives us y over x. And from the triangle, tan theta is y over x. That is the proof of this. Take note of this. It's very, very important. Now, you want to prove the second identity, which says sin square theta plus cos square theta equals to 1. It's a very important identity. How do we arrive at here? Now, let's see. Now, recall that we just, when we were dealing with identity 1, we wrote that sin theta is y over r, which is opposite over hypotenuse, and cos theta is x over r, which is adjacent over hypotenuse. Now, if I square sin theta, that will give me y over r all raised to power 2, and if I square cos theta, it will give me this raised to power 2. Now, if I now add these two together, that means sin square theta plus cos square theta will be y over r all squared plus x over r all squared. Don't forget, this power is affecting both y and r. So definitely, I'm going to have y squared over r squared plus x squared over what? R squared. And at the end of these two, because the denominators are the same, that will be x squared plus y squared all over what? R squared. Okay. Having done this, I will now go back to this triangle and find this r. From the triangle, using Pythagoras theorem, r, which is the hypotenuse, square of it equals to the sum of the squares of the other two sides. Hypotenuse square equals to opposite square plus the adjacent square. That means I can use x squared plus y squared to replace what? R. Now, coming to this now, that means definitely from where I stopped here, I can now use r squared to replace what? X squared plus y. So this implies from x squared plus y squared over r squared, that will now be equals to x squared plus y squared, which is r squared, over r squared. And what does that give me? 1. R squared cancels r squared. That is how to prove the second identity, sin square theta plus sin square theta equals to 1. It's important you note this, that when we write sin square of theta, it's the same thing as raising the whole of sine of theta to power of 2. And when we write cosine square of theta, it's the same thing as raising the whole cosine of theta to power of what? 2. So whenever you say power on sine or cosine, it means it affects the whole of it. This will be the end of second episode on trigonometry. From the two identities we are proving today, We are going to develop more identities in the next episode, and possibly we solve questions using the identities in the next episode. Do not miss any of the episodes. See you in my next episode. Bye for now.